So our last question, it looks a lot like kind of what we started this unit with and like the quizzes that we did or the skills check that we did. So with this one, we're saying we have a rigid rod. It's one end can pivot, so we're pivoting around this end. And we have two forces acting on it. One is this 10 Newton force that's acting at an angle, and then one is this downwards force that is applied to the end of the rod. And the main thing is that the rod is remaining at rest. So we are in this static equilibrium. We know when we're at rest and remaining at rest, our net torque is equal to 0. So we want to just know what's the magnitude of the torque produced by this force over here. So what we're really asking, what we're really saying is, well, the net torque, I'm going to call this torque 1, and I'm going to call that torque 2. We have a positive, or I guess it doesn't really, let's see, this is making us rotate in the counterclockwise direction, and this is going to make us rotate clockwise. So we have a positive torque 1 minus torque 2 equals 0 because our net torque is 0. So torque 1 is equal to torque 2. So if we can find the value of torque 1, we know the value of torque 2. So let's do that. Let's figure out the value of torque 1. We know that a torque, label them again. So we know that a torque is a force that is acting some distance away from our pivot point. In this case, our distance away is 1 meter. And our force, it has to be the perpendicular component. So that's really the hardest part here, is saying, hey, we have this force that's acting at an angle. Some of it is parallel, and then some of it is perpendicular. So we just need to find this perpendicular component. What's nice is we have a good triangle right here. We have a nice right triangle. We say this is 37 degrees. So this has to be, what, 53? 90 minus, oh wait, no, 90 minus 37. Oh yeah, 53. This is 53 degrees. That means that this has to be 37 degrees. So what we're really looking at is we know the hypotenuse is 10. We know that this angle right here, I don't know why I made it so small. This angle right here is 37, and we need this perpendicular piece. So we know that sine is equal to opposite over hypotenuse. So our sine of 37 equals f perpendicular over 10. So f perpendicular is equal to 10 sine of 37, which equals, equals 6.018. So that's our perpendicular force. So torque 1 is equal to 1 times 6.018. And we know that torque 1 equals torque 2. So our answer is just 6.018, which is pretty close to 6. All right, and that is that. Hopefully that was good practice and not too overwhelming. All right.